Hi there, and welcome to the hearing test data analysis walkthrough. This is meant for the hearing test data analysis assignment that we did in class on 4/9, 4/10, and we're going to show you how to go through this stuff. So once you open the assignment on Canvas, you will see this on my screen, and we're going to start by our class data. So the lab question that we set out to answer is, does your age affect how well you can hear? We took a hearing test yesterday, and I compiled all the data for you, and we're going to go over that data like scientists do. So first things first, we're going to open up this link and make our own copy. So this, when you click on this, open, and it will force you to make a copy, like right here, make a copy. And you should be looking at this. Now, here's what we need to do. You need to make sure that you need to be working with the bell that you are assigned to. So I have bell 2, bell 3, bell 6, bell 7, and bell 8. All of that is at the bottom. So make sure you are working with the correct bell on the bottom there. Okay? So I'm going to go with bell 3, I think, because they have the most data. All right. Yep. Let's work with bell 3. All right. So this is what I'm going to be working on. So I've done that. So I've done step 1. I've done step 2. Okay. And now here are my instructions. Make sure we label the axes. So what we're going to do is we're going to make a graph that shows us the relationship between age and the highest frequency you can hear. All right. So on your data table, which is here, you can see that you have one for age and one for frequency. So what you're going to do is you're going to click on the age column so it highlights the whole thing. You're going to hold down shift, and then you're going to click on the B column. What that does is that highlights both columns at the same time, and that's what you want. Hold down shift, hit B, you should have both of these columns highlighted at the same time. To insert a graph, you click on insert, and then you come down to chart. So again, insert, scroll down to chart. You're going to get something that looks like this when you start, but we want to change the chart type. So click on chart type and click on this scatter chart is what you want. It's under the suggested. You can also scroll down and click on the scatter chart here. All right, so I'm going to click on this one, and this is what I'm looking at. This is exactly what you should see. If you're feeling fancy, you can click on customize and change anything you click on. So if I, for example, wanted to make the chart title bold, and let's put it in orange and center it, if you're into that kind of thing, you can go ahead and do that, but you don't have to. It does help just kind of make things a little bit easier to look at. All right, so this is my chart. I'm going to click on it. Control C copies the chart. I'm going to come back, and where it says insert the graph below, I'm going to hit Control V to paste it. You want to make sure your spreadsheet is linked. Make sure you have link to spreadsheet selected and click paste. And this is what you should see. All right. If you would like, you can resize it to kind of fit your screen a little better, whatever floats your boat. So that is what we've done so far. So you should have this chart in your assignment. So next we're going to look at these questions. The first part is probably the most involved, put it that way. We have more questions to answer here, but once we get through this part, the rest of them are a little bit easier and just kind of quick. So we spend a little bit more time in this first part than we do the other ones, but that's okay. So what's the independent variable? All right, the independent variable, the two variables we have are age and we have frequency, age and frequency. Those are the two variables we have. So which one's independent? Remember, independent means which one is unrelated or is not affected by the other one. So you got to think, is age, does that affect the frequency? or does your frequency you hear at determine how old you are? Okay. One of those makes more sense than the other. Okay. So age determines your frequency. So that means the independent would be age, and your dependent variable would be frequency. So your age is independent of the frequency. The frequency depends on your age. It's a good way to think about it. So what is the trend we see in this graph? Now you can look at this and summarize what you are looking at and just kind of think, oh, that's what's happening. So you can see how the dots shift from 15 to 16 to 17, and you can tell me what's happening as that goes on, or you could draw a trend line. So let me show you how to do a trend line that makes your life a little bit easier. So click on this chart or double click, and you're going to go to customize, and you're going to click on the series drop down menu and scroll down till you see something that says trend line. This is what you're looking for right here. This trend line shows you the trend. So it shows you a basic line or slope of all your points in what direction they're heading. All right, if you want, you can kind of, I'm going to make mine a little bit bigger in a different color so that it sticks out a little bit better. So that red line here is what we're looking at. All right, so that's the trend. So it shows the general trend of all the data in what direction it's moving. So as your age increases, your frequency follows this line in general. That's the trend. So answer that here. What is the trend you see? Do you see it going up? Do you see it coming down? Is it staying the same? All right. Now, when you come back here, you're going to see, oh wait, where's my trend line? That's the beauty of doing this in Google Sheets in Docs, is because you can click this update button and bam, there it is. It updates it in real time. You don't have to recopy paste it. And if you took a screenshot, you would have to redo all of that, and that saves you time. So now we can see this trend line, and you can answer question 3. What trend do you see? Okay. How many people were in this research? All right. If you go back to this, and you look up, there's a box that says number of participants. You will fill in that number. We're going to come back to that in a minute. Okay, so now we're going to check all the boxes that apply to this data set. So we're going to look at our data set, and we're going to ask ourselves, are these things true? All right, in science, taking good data is important. You can take data, anything, but it's not always good quality data. So we're going to check these 5 things to see if our data is quality or not. So first, we got accuracy. When we talk about accuracy, it is the information correct. That means, are there any mistakes? Are there any outliers? And what does it mean for our data? So an outlier is something that lies outside the general trend. So when you look at this, all right, you might see one of these that doesn't belong. Which dot doesn't belong? All right, you can see that there's one down here. All right, this one it's kind of hiding. It's by the 0 and 15 mark. So that one looks weird. It's way outside. So our data is not accurate. All right, there is information that we need to fix. Okay, so to fix that data, you can look over your data set. Which one of these has the mistake? Okay, I'll look closely at the highest frequency. One of these has a mistake in it. Okay? One of these has a mistake in it. Can you find it? All right, I did that for every data set too. Every data set, no matter what you're working with, has a mistake in it. Okay? You need to find that mistake and fix it. Okay? So make sure you fix the mistake in order to increase your accuracy. Once you find the mistake and fix it, you can come back to your chart and you can see that the update is there. So when you update it, that changes things for you. Okay? That is way different than the other one. So if I go back and forth, you can see that there is a big difference. This is before and this is after. Before, after. There's a big difference in your line there. Okay, this line is not so definitive in what you're doing, so you're going to have to change your answer to number 3. All right, and there's a reason why I didn't go ahead and tell you that, is because I want to make sure that you're following along and doing this correctly. So don't forget to change your answer to number 3. So now we can check that this data is accurate. All right, is it complete? How complete is the data? Does the data represent enough people? All right, so you did 13 people in this trial, and in all the other tabs, there's different amount of people. But if you think about it, is that enough? Do you think we represent the right ages? All right, I want you to, if we think about this, it'd be like if you wanted to order pizza for the entire school and you only asked one class, all right, about the toppings we should put on that pizza, you'd probably get yelled at because not everybody likes the same toppings. But if one class happens to like the same weird anchovies on their pizza, then that's going to cause a problem for everybody ordering the food. So think about it like that. Is this data complete enough that it surveys enough people that it comes up with a good, complete answer? I don't think this is true. 13 people, not enough people to survey. All right. Is it reliable? All right. Come from trusted sources. I would say you guys are pretty trustworthy. So let's say yeah. All right. And then do you need this information? We're trying to answer the question, does your age affect how well you can hear? All right. Yes, we need this information. All right. If I asked you, if there was in this chart something about like your favorite color, that has nothing to do with what we're asking. So then that wouldn't be relevant. So since the data that we gathered is relevant, check that box. Time. All right. We took this data yesterday, so you should be good to go on time. It's pretty up to date. So then, based on the questions in question 5, that's a typo. All right, what is the quality of this data? All right, so you don't have to give a yes or no answer here. It can be a little bit of both. All right, you can give an answer that's not black or white. You can give it in the middle. So you can say that our data is pretty reliable, except it's not complete. And then say why. If we surveyed more people, then our data would be more complete and we would have more quality data. Right, that's the kind of answer I'm looking here. Complete sentence. All right. It should not be all or nothing. Okay. That takes us to all class data. So this is the data I got for all of my bells. So that is all of the bells combined into one data sheet from this year alone. So when you look at that, you have the same ages across the bottom and you have frequency going up and down. So you can see this trend line, again, shows the general trend of what's going on here, right? And you have 45 people that participated in all of the classes. So the chart above is from all my classes this year, all right? What is the relationship between the highest average frequency each age group could hear? Okay, remember the red line is the trend line, or like I just said. So talk about the trend line, all right? How does it look? How is it changing between the ages of 14 and 17? All right, how does it change? Is it changing at all? Okay. So that's fine. Whatever you come up with there, just make sure you give me a complete answer. All right, let's look through this stuff again. Is it accurate? All right, yeah, that is accurate. I don't see any major outliers. Okay, so there's nothing like all the way up at the bottom, all the way at the bottom. We don't have someone that's like 80 years old or 10 years old on this chart. It's pretty tight. Everything is the same. So I would say, yeah, completeness. All right, now again, 45 people. All right, that's a lot more than last time. But again, if we're trying to see if there's a trend here or if this is true, 45 people still kind of on the small end. All right, so I would say that we still don't have enough people. All the other information is true though. All right, really need it. So you can see we're rinsing and repeating here, so it's a little bit goes a little bit faster. All right, you don't have to do as much. So in question 8, is this data quality? All right, give a similar answer as you did in question 6, where yes, it's pretty good, but we could have more people. It's not as quality as it could be. All right. Again, you're allowed to give an answer that's in the middle of the road. Okay, moving on. All-time data. So I've done this lab for 3 years. So this is the data from all 3 years combined, all right, including yours. So I added yours in. So if yours doesn't say update, make sure you update it so it looks like mine. So I've noticed that in some classes, this is not updated all the way, which may change your answer. So we have done 207 people in this time. That's much better than the other one. So we can do the same questions, all right? How does over the past 3 years, what is the relationship between age and highest frequency age group here? All right. So bring in everything you've observed so far. If you look at the data, that's pretty flat. This one's pretty flat. All this stuff lines up. Okay. You can see you are hitting the nail on the head when it comes to consistency. You are showing that you have consistent results here. Talk about it. Okay. Talk about how the age going up sort of doesn't affect the frequency. It stays about the same. If you're going to look in really close, you can see, like, if you were to put like a race car on here, or a ball, it would roll slightly this way. So it's getting a little bit worse, just a little bit, but not enough to really tell. Okay? Talk about that here. All right. You can go ahead. I would check all these boxes now. All right. Except completeness again. Let's talk about this. It's still not very complete because we're only looking at ages 14 to 19. All right. That is not very wide. If we're talking about, does your age affect how well you can hear? That's hard to say because you're not really checking everybody. You're kind of just checking high school age kids. All right. That should be part of your answer for number 11. Okay. So think about that for question 11. Is this data quality data? Again, you can have a gray answer. Yes, it's better than what we've done. However, we're missing something about how the age range is still very specific. It's not wide enough to make a good answer. So hopefully you see this trend now of how to determine if your data is good or not. Going into this last question, it's a little different. All right. So we are looking at same stuff. All right. So is this good data? So this is from the website, what we did the test on. So if I go there and I go down to the bottom after you did the test, it says, how does your hearing compare? All right. Once you get here and these graphs load in, this is where I got the information from. This graph right here. All right. So this is this. So this does 350 people. So much more than we've done, over 150 more people. All right. And you can see that it's a much greater age range. Ours only comes from, let's see if this will let me zoom in. Right about, oops, I lost it. Let me zoom back out. That did not work like I thought. Ours only comes from right about here. Okay. We're in this age range of 14 to 17 or 19 years old. Okay. That's not as big as the whole thing. So this checks all the boxes now. Okay. You've done all of this. It's much more complete than it is before. And you can go ahead and answer that. All right. Based on the boxes, is it complete? Yes, it's complete. Talk about how it has a wider range of people present and more people surveyed. So then this is the big question. All right. How does our data from our classes compare to the large group data? Okay. So Does it support or reject? This is the key part. All right, I'm looking for you to talk about, did you support or reject the findings? Okay, so we only looked at right here. All right here in this little section here. But if you look at the overall trend, you can see that there's a very clear decline in highest frequency. Because if you drew a box that would keep the majority of the dots in there, it would look something like this. You're going to have your outliers here and here and here, and that's fine. All right. You're going to have some people that are older that have excellent hearing, like this one up here. All right. But you might have some people that are younger with terrible hearing. That's fine. The majority of dots fall in this trend, which is going down. Okay. And that's what I want you to focus on when you answer this last question. And again, you can talk about everything. All right. You can come up with a little bit of each. It shouldn't be a straightforward answer. This is kind of a roundabout answer. You're talking about how our data showed one thing, okay? Look at this line. It's not going down as much like this one is. But if you zoom in really close right here, it kind of is. It kind of is talking about it matches. All of the lines, if you were to connect the dots from, let's say, 14 to 17, which is right below this 25 line right here where my mouse is, that kind of checks out. Everyone's hearing is kind of on par, on level. So our data is pretty good. It also supports this. All right, but talk about the larger trend is that our data was not complete enough to find the major trend, but we did fit in the large study. Okay? So I hope this helped you figure out how to complete this assignment. You didn't need to be present for the testing in order to complete this and follow this video. Feel free to go back, pause, rewind, go slower, look at captions to make this make more sense to you. If you need help submitting or anything else, find me in class. Thanks for watching, and I'll see you around.